Voltage, also known as electric potential difference, is a fundamental concept in electricity that describes the force with which electric charges are pushed or pulled through a circuit. To understand voltage, it is helpful to first consider the concept of electric charges. Electric charges can either be positive or negative, and they are attracted to charges of the opposite sign and repelled by charges of the same sign. When there is a difference in the electric charge between 2 points in a circuit, there is a force that pushes or pulls electric charges from one point to the other. This difference in charge is called voltage, and it is measured in volts, V. Voltage can be visualized as the pressure that drives electric charges through a circuit, similar to how water pressure drives water through pipes. Just as water flows from a high-pressure area to a low-pressure area, electric charges flow from a higher voltage point to a lower voltage point. Voltage can be produced by a variety of sources, including batteries, generators, and power supplies. In a circuit, the voltage is typically represented by the symbol V and is measured using a voltmeter. It's important to note that voltage alone does not determine the strength or amount of electric current flowing through a circuit. Other factors, such as the resistance of the circuit and the amount of charge available, also play a role in determining the flow of electric current. However, voltage is a key factor in understanding how electric charges move through a circuit and is an essential concept in the study of electricity. Voltage has several effects on a circuit, including current flow. Voltage is the driving force behind the flow of electric current in a circuit. Higher voltage means more potential energy to push electrons through the circuit, resulting in a greater current flow. Power consumption. The voltage applied to a circuit affects the amount of power consumed by the circuit. The power consumed by a circuit is equal to the voltage multiplied by the current flowing through the circuit. Therefore, a higher voltage will result in a higher power consumption for the same amount of current. Heat generation. The amount of heat generated in a circuit is proportional to the amount of power consumed. Therefore, a higher voltage applied to a circuit will result in a higher heat generation, which can lead to overheating and potential damage to the circuit. Electrical safety. High voltages can pose a serious safety hazard to people and equipment. Therefore, electrical systems are designed to operate at specific voltage levels to ensure safe and reliable operation. Electrical noise. Voltage fluctuations in a circuit can create electrical noise, which can interfere with the operation of sensitive electronic equipment. Overall, the effects of voltage on a circuit depend on the specific application and the design of the circuit. Understanding the effects of voltage is essential for designing and operating safe and reliable electrical systems. There are several ways to generate voltage, including chemical reaction. Batteries generate voltage by converting chemical energy into electrical energy through a chemical reaction. Electromagnetic induction. Voltage can be generated by moving a conductor through a magnetic field or by moving a magnetic field past a conductor. This principle is used in generators to produce electricity. Thermoelectric effect. Voltage can be generated by heating the junction of two dissimilar metals or semiconductors, which produces a temperature difference that generates a voltage. This principle is used in thermocouples and thermoelectric generators. Photovoltaic effect. Voltage can be generated by exposing certain materials to light, which produces a flow of electrons that generates a voltage. This principle is used in solar cells to convert sunlight into electricity. Piezoelectric effect. Voltage can be generated by applying pressure or strain to certain materials, which produces a voltage. This principle is used in sensors and transducers. Overall, the method used to generate voltage depends on the specific application and the requirements of the system. Different methods may be more or less suitable depending on factors such as the amount of voltage required, the reliability and efficiency of the system, and the environmental conditions in which the system will operate. There are several common sources of voltage, including batteries. Batteries are a common source of voltage for portable electronic devices such as cell phones, laptops, and flashlights. They generate voltage through a chemical reaction that converts chemical energy into electrical energy. Power supplies. Power supplies convert alternating current, AC, voltage from an electrical outlet into direct current, DC, voltage that can be used to power electronic devices. Power supplies are commonly used to power desktop computers, televisions, and other electronic devices. Generators. Generators convert mechanical energy into electrical energy through electromagnetic induction. They are commonly used to generate electricity in power plants and to provide backup power in emergency situations. Solar cells. Solar cells convert sunlight into electrical energy through the photovoltaic effect. They are commonly used to power small electronic devices such as calculators and outdoor lighting systems. Alternators. Alternators are devices that convert mechanical energy into electrical energy through electromagnetic induction. They are commonly used in cars to generate electricity and recharge the battery. Overall, the specific source of voltage used depends on the requirements of the system and the availability of power sources in the environment. Different sources of voltage have their own advantages and disadvantages in terms of cost, efficiency, reliability, and environmental impact. Advantages of voltage. Voltage is a key parameter in electrical systems and is essential for the flow of electric current. By controlling the voltage applied to a circuit, the amount of current flowing through the circuit can be controlled, which allows for the efficient use of electrical power. Voltage can be generated from a variety of sources, including chemical reactions, electromagnetic induction, and solar energy, which makes it a versatile and widely available form of energy. Applications and uses of voltage. Electrical power distribution. Voltage is used to transmit electrical power over long distances from power plants to homes and businesses. High voltage is used to minimize energy losses during transmission. Electronic devices. Voltage is used to power electronic devices such as cell phones, laptops, and televisions. These devices typically require a specific voltage level to operate correctly. Automotive industry. Voltage is used to power automotive systems such as ignition systems, lighting, and accessories. Alternators in vehicles generate voltage to charge the battery and power the electrical systems. Renewable energy. Voltage is used to generate electricity from renewable energy sources such as solar, wind, and hydroelectric power. Solar cells generate voltage from sunlight, and wind turbines generate voltage from the wind. Industrial applications. Voltage is used in a variety of industrial applications, including motors, pumps, and lighting. Industrial equipment typically requires specific voltage levels to operate correctly. Overall, voltage is a fundamental concept in electricity and is essential for the efficient use and distribution of electrical power. It has a wide range of applications in various industries, including power generation, electronics, automotive, and renewable energy.